Okay, so in this video I want to talk about the relationship between distance, velocity, and acceleration. You may know something about this if you've taken some physics, perhaps in grade 11. I think they do mention it also a little bit in grade 10 as well. Now let's first recall the definition of velocity, or some of you might be more comfortable with speed. Velocity is essentially speed. So velocity is speed with direction. Okay, so if you say 30 meters per second, that's speed. But if you say 30 meters per second going up, then we're talking about velocity. We're giving it a direction in which the speed is happening. So speed is defined to be the change in the distance divided by a certain given time interval, so it's also change in time. Okay, so the delta D, we say destination distance, the starting distance, the finishing time minus the starting time. Okay, if you're to draw a graph, okay, let's say you have a curve like this, and this is distance. We use S for distance a lot, T for time, and let's say that right there is T1, and let's say this is T2, and this right here will be represented, it's as S1, or in this case I should maybe label it, let me label this S2, S2 and S1, just to be consistent with the graph. Okay, so this is S1, this is S2. So the slope here, right, the slope here is, this right here will be delta S, this is delta T. But this is what we've been talking about when it comes to derivatives, right? So this is a secant, essentially a slope of secant between these 2 points. But what happens if you take the second T2 closer to T1? So what happens if you take the limit of T2 to approach T1 for this expression? What we get is the derivative of distance at time 1, right? We're going to get the instantaneous slope right there. So the instantaneous velocity at time 1. Right. If you're given a distance as a function of time, we can say the D, so this is actually why we use S. Okay, let's say S is the distance, ds over dt. So if I use D, it'll be dd over dt, and it's kind of confusing notation. ds over dt, which can be notated by f prime at t, right? This is equal to the velocity at t, okay, the instant velocity at time t. Now let's talk about acceleration. Okay, acceleration. So what is acceleration? Acceleration is how fast the speed changes. So it's really just nothing more than delta v over delta t. Right, delta v over delta t. So you can write this as v2 minus v1, t2 minus t1, exactly the same pattern as above. And if we consider again the limit of t2 approaching t1, this is the derivative of v at t1. Okay, so essentially that means dv over dt is the acceleration. So there's two types of examples that we generally will discuss in this section. One is a projectile moving up and down, and we're calculating what happens to the projectile at a certain time. And another is a particle, a movement of a particle, whether it's moving forward or backwards. So I'll discuss those two examples following this video.